Imagine you are a soldier on a beach in 1950. The army behind you has just won the largest land revolution in human history. It has millions of men, thousands of artillery pieces, and a will to fight that stopped the world's most powerful military in its tracks in Korea. But it cannot move a single infantryman across open ground under fire in an armored vehicle it designed itself. Not one. Everything it has been borrowed, bought, or copied from a country that was already pulling its advisors out and shredding the blueprints on the way to the airport. That is where the story begins. Not with a triumph, but with a gap. A country of 600 million people that could not build the most basic armored box on tracks. What happened next? Across 7 decades, through political catastrophe, international isolation, forced reverse engineering, and finally genuine innovation, is one of the most dramatic industrial transformations in military history. This is every armored fighting vehicle China ever built. 22 platforms, 7 decades, and a journey from copying a Soviet truck to building the fastest amphibious assault vehicle on Earth. Chapter 1. Steel Without a Blueprint, China's Soviet Shadow and the First Tracks. The People's Liberation Army that emerged from the Chinese Civil War in 1949 was a foot soldiers' army. What little armor it possessed came from 2 sources: captured nationalist vehicles and Soviet handouts. The first real armored personnel carrier in Chinese service was the Type 56, a 6-wheeled machine that arrived in 1956. It was not designed by a Chinese engineer. It was a direct copy of the Soviet BTR 152, reproduced under license, component by component, down to the rivets. It could carry a squad of infantry, protect them from small arms fire, and move them at 65 kilometers per hour on a good road. It was a start, but it was entirely someone else's idea. The Type 66 came next, and it was the same story. A tracked machine designed to move infantry behind tanks, it was a near-exact replica of the Soviet BTR 50P. China was learning to build armored vehicles the way a student copies an exam, without fully understanding the material. And then there was a third inheritance, one that would matter more than the others. The Soviets had a light amphibious tank called the PT-76. China copied that too, and the hull and suspension technology from that program became the starting point for the most important original armored vehicle China had yet attempted. In July 1958, the central government issued a directive. China needed a domestically produced, tracked armored personnel carrier ready for mass production within 2 years. The timeline was fantasy, but the intent was real. The Yongding Machinery Factory, later absorbed into the enormous Norinco Industrial Group, was given the task. What emerged, after years of delay, prototype failures, and engineering struggles with no Soviet help and no Soviet blueprints, was the Type 63. Its industrial designation was the YW-531. And it matters for one reason above all others. It was the first armored vehicle China designed entirely without Soviet assistance. It first rolled out in 1964. Early batches were unreliable enough that the formal production version did not reach full PLA service until 1970, but when it did, it proved itself a solid, practical machine. Tracked, amphibious, carrying up to 13 passengers in a welded steel hull, powered initially by a Chinese 6,150L diesel producing 260 horsepower. Simple, exportable, durable. The Type 63 saw combat in the Vietnam War, in the Iran-Iraq War in Iraqi hands, and notoriously on the streets of Beijing in June 1989, when its image became inseparable from one of the most watched political moments of the 20th century. Norinco eventually produced approximately 8,000 Type 63s across all variants. That figure made it the third most widely manufactured armored fighting vehicle in world history by total production. 17 major variants emerged from that single chassis, including the Type 70 self-propelled howitzer with a 122mm gun, a 1.9 tube 130mm rocket launcher, armored ambulances, command posts, and a cryptography vehicle that was still being delivered in 1992. Iraq alone operated over 650 of them. Many were destroyed in the war against Iran. More were wrecked by coalition forces in the Gulf War. The Type 63C variant, the most produced version, swapped the original water-cooled Chinese diesel for a German KHD BF8 L413F air-cooled turbocharged engine, producing 320 horsepower. That engine choice was its own quiet admission. Chinese power plant technology in the early 1980s still could not match what a West German commercial supplier was selling off the shelf. And running parallel to the Type 63's long service life, Norinco was already developing what would become a family of improved tracked APCs, each one a step beyond the last. Chapter 2. The APC Family Tree, from the Type 85 to the Type 90. The Type 63 did not stop evolving. It grew. The Type 85 APC, industrial designation, YW531H, entered production in 1990. It used the same torsion bar suspension and general layout as the Type 63, but with a larger, more modern hull, better seating for troops, improved crew ergonomics, and the same 320 horsepower Deutz diesel. It wasn't a revolution, it was a refinement, but it mattered because it became the genetic foundation for the next two machines in the family. The Type 89, redesignated ZSD 89 under the new PLA naming system, industrial designation WZ534, was a direct evolution of the Type 85, slightly larger, slightly heavier at 14.3 tons, still carrying 13 passengers, still powered by the German Deutz air-cooled diesel. It entered service in the late 1990s and was first shown publicly during the 1999 Beijing military parade. Norinco built approximately 1,000. But what made the ZSD-89 interesting was not the base vehicle. It was the YW307, also called the Type 89-2. Chinese engineers took that ZSD-89 hull and fitted it with a one-man power-operated turret carrying an externally mounted 25mm autocannon and a coaxial machine gun. That conversion gave a basic APC hull genuine IFV firepower without waiting for a purpose-built infantry fighting vehicle to arrive from a program that was taking years longer than anyone planned. The Type 90 APC, industrial designation YW535, took a different direction. Designed in the late 1980s, primarily for export, it entered production in 1991. The hull shape was different from the Type 85 and Type 89, with vertical lower sidewalls and a sloping upper hull that gave it a lower silhouette. It was bigger than its predecessors, with space for up to 15 personnel, including crew. Norinco produced it in at least 10 variants for export customers, including Sudan, Sri Lanka, and Cambodia. 3 parallel-tracked APC families, the Type 85, the ZSD-89, and the Type 90, in overlapping production through the 1990s. That proliferation was not the result of a unified strategic plan. It was the result of Norinco responding simultaneously to PLA requirements and a long list of foreign customers who each wanted something slightly different and were willing to pay for it. But while the APC lineage was evolving in this careful, iterative way, a far more urgent problem had been festering since 1979. Chapter 3. The BMP Problem, From Vietnam's Jungle to a Stolen Blueprint. In February 1979, China invaded Vietnam. It sent over 200,000 troops across the border in a punitive campaign that was supposed to last weeks. The fighting was brutal, costly, and deeply instructive. Chinese infantry advanced on foot, exposed, with APCs that were too lightly protected and too poorly armed to provide meaningful fire support in jungle terrain. The Type 63 APCs that made it into the battle were simply not designed for that kind of close-quarters, mechanized warfare. The Soviets had solved this problem 13 years earlier, in 1966, with the BMP-1, an infantry fighting vehicle rather than a mere carrier. It gave the infantry a 73mm smoothbore gun, anti-tank missiles, and the ability to fight from inside the vehicle. China had nothing comparable. Development of a Chinese IFV began in 1980, under the factory designation WZ-501. The approach to solving the capability gap was, by that point, entirely predictable. China obtained a BMP-1 through undisclosed channels, dismantled it, studied every component, and spent approximately 5 years reverse engineering it. The result was the ZBD-86. It was officially accepted into Chinese service in 1986, 20 years after the original BMP-1. Full-scale production did not begin until 1992, 26 years after the Soviet vehicle it copied had first appeared. By the time the ZBD-86 reached meaningful numbers in PLA service, every serious military in the world had already moved on to second-generation IFVs. Production estimates range from 1,000 to 7,000 vehicles. The uncertainty itself, a reflection of how difficult it is to distinguish the ZBD-86 from the original BMP-1, even in photographic evidence. The ZBD-86 was not without variants. The WZ-503 was an armored personnel carrier version. The WZ-504 was a tank hunter. The WZ-505 was an armored ambulance. The WZ-506 became a command post. Chinese engineers were industrious with the platform, even if they had not originated it. The ZBD-86's legacy reaches further than China. Iran developed the Bora IFV directly from the ZBD-86 design, and the Bora remains in Iranian production as of 2025. A 1960s Soviet concept, filtered through a Chinese copy program from the 1980s, still rolling off assembly lines in the 21st century. But the ZBD-86 also produced one useful hybrid. Chinese engineers placed its original 73mm armed turret onto the hull of the newer Type 85 APC chassis, creating the YW-309 IFV. It was a stopgap, a way to give mechanized infantry some IFV firepower while the dedicated production lines were still being organized. It was never a headline system, but it filled a gap that was otherwise completely open. The Type 86G upgrade, meanwhile, tried to give the base ZBD-86 a longer lease on life. Out went the 73mm gun. In came a one-man turret with a 30mm cannon and a launcher for the HJ-73 anti-tank guided missile. The result was still, at its core, a 1960s-era concept wearing newer clothes. The ZBD-86 taught China something it had not learned from building the Type 63. Copying a platform without copying the doctrine that created it, and without understanding what the next generation was going to demand, left you perpetually behind. That lesson drove the next program with unusual urgency. Chapter 4. Buying the Brain, the ZBD-04, the Wheeled Revolution, and China's airborne leap. In the early 1990s, the Soviet Union collapsed. Russia needed hard currency. China needed technology. The transaction that followed reshaped everything. In 1996, China imported the BMP, 3M turret and weapon system technology from Russia under license. This was not simply buying a vehicle and copying it. This was acquiring the actual fire control architecture, the actual gun, the actual integration between sensors and weapons of one of the most heavily armed infantry fighting vehicles on Earth. The BMP-3's combination of a 100mm low-pressure rifled gun capable of firing laser-guided anti-tank missiles, paired with a 30mm autocannon in the same turret, was a weapon system no Western IFV had matched at the time. Chinese engineers did something significant with what they received. They did not copy the BMP-3 hull. They built their own chassis and their own turret around the Russian weapon system, producing the ZBD-97 prototype, first seen in testing in 1997. 4 years of ironing out problems followed. The ZBD-04 entered formal PLA service in 2006, deployed to the Guangzhou and Nanjing military regions, where Taiwan contingency planning dominated operational thinking. The weapon system was formidable. The 100mm gun-fired programmable airburst shells, bunker-busting rounds, thermobaric shells, and laser-guided missiles out to 4,000 meters. A millimeter-wave fire control radar above the gun gave the ZBD-04A, the upgraded variant, also known as the ZBD-08, the ability to engage targets with top attack missiles, something no other IFV in the world fielded at that time. The ZBD-04A added applique armor and a more powerful 670 horsepower engine, pushing combat weight to 24 tons. Over 3,075 vehicles of all ZBD-04 variants were built. The AFT-10, a dedicated anti-tank missile launcher on the ZBD-04A hull, carrying the HJ-10 fire and forget missile with a reported range of 10 kilometers, gave mechanized brigades a long-range armor-killing platform without needing a separate tank destroyer in the order of battle. But tracked IFVs were not the only direction China was moving. The WZ-551 had actually appeared before all of this, entering service in 1990 as China's first domestically designed wheeled armored vehicle. A 6-wheeled machine developed at the Norinco Vehicle Research Institute, it weighed between 12.5 and 15.8 tons depending on configuration. Its engine, again, was the German Deutz Bf8 L413F. It carried 9 passengers and became the foundation for the entire ZSL-92 family, which would eventually spawn variants ranging from a basic APC with a 12.7mm machine gun to the PTL-02 fire support vehicle with a 100mm anti-tank gun. Export customers across Africa, the Middle East, and South Asia bought it extensively. The WZ-551's descendants saw action in the Boko Haram insurgency, the Somali Civil War, and the Tigray conflict. And then there was a completely different problem. What does an airborne force ride? The ZBD-03 answered that question. Industrial designation, WZ-506. Early prototypes, designated ZLC-2000. It was the first Chinese armored vehicle designed from the outset to be dropped from an aircraft with its crew and passengers still inside. Development began in 1998, drawing visual inspiration from Russia's BMD-3 while using an entirely indigenous chassis and internal layout. Weight was critical. At just 8 tons, the ZBD-03 could be rigged to an Il-76 transport aircraft's parachute system and delivered directly onto a contested drop zone. It entered PLA Air Force Airborne Corps service in 2002. Armed with a 30mm autocannon, a 7.62mm coaxial machine gun, and an HJ-73C anti-tank guided missile, it gave China's paratroopers their first credible organic armored firepower. At least 180 ZBD-03s were in service with the Airborne Corps as of 2021, alongside command post and ATGM launcher variants on the same chassis. For the first time, Chinese soldiers jumping out of aircraft could expect armor to arrive with them. The 8-ton weight limit required for airdrop, however, meant something had to give. The ZBD-03 was lightly protected. It would stop small arms fire and shell fragments. It would not stop a heavy machine gun at close range. For the heavier, protected IFV that the PLA's ground forces needed, something else entirely was under development in the early 2000s. Something that didn't need a parachute. Something that needed a hull that could plane across water at speeds that seemed physically impossible for a vehicle that heavy. Chapter 5. The Beach Assault ZBD-05, ZTD-05, and the Amphibious Doctrine. The requirement that produced the ZBD-05 was unlike anything that had driven a Chinese armored program before. Not the need to copy a Soviet design, not the need to keep up with a peer competitor. This was a requirement built around one specific scenario, one body of water, and one island 180 kilometers away. China needed a vehicle that could leave a warship, swim to a beach under fire, and arrive with its infantry ready to fight, without waiting for landing craft, without being concentrated into the most vulnerable possible formation during the most dangerous phase of any amphibious operation. The engineering problem was water speed. Conventional amphibious APCs of the era moved at 6 to 8 kilometers per hour in water. At that speed, crossing a defended strait took hours. Hours in which the vehicle was a slow, predictable target. Norinco's designer Chen Pengfei led the effort to solve it. The solution was a hydroplaning hull, shaped not to push through the water but to ride on top of it at speed, combined with twin water jet propulsion systems at the stern. Final trials, completed in December 2004, proved the concept. The ZBD-05 achieved 28 to 30 kilometers per hour on water. That figure made it, upon its public unveiling in 2009, the fastest operational amphibious infantry fighting vehicle in the world. On land, a 550 horsepower diesel pushed it to 65 kilometers per hour. The turret carried a 30mm autocannon and the HJ-73C anti-tank guided missile. 3 crew, 10 fully equipped Marines in the rear compartment. The hull was aluminum alloy and steel with composite armor panels. The ZTD-05, the assault gun variant of the same Type 05 family, replaced the 30mm turret with a 105mm rifled gun. Its design involved collaboration with Russia's Tula KBP Bureau, and the fighting compartment drew conceptually from the BMP-3's weapon system integration. The ZTD-05 replaced the obsolete Type 63A amphibious light tank, a 1997 era upgrade of the original Type 63 hull that had been fitted with a 105mm gun and an upgraded diesel producing 581 horsepower, capable of 75 kilometers per hour on land and an extraordinary 28 kilometers per hour in water. The ZTD-05 gave Marine Assault Forces something even the Type 63A could not properly provide. It gave them a vehicle capable of taking on hardened positions and enemy armor the moment the bow ramp dropped, without waiting for main battle tanks to be ferried ashore by separate means. Production of ZBD-05 vehicles exceeded 1,000 units by 2015. Venezuela's 2012 defense package from Norinco, worth $500 million, included both the VN-18, the export designation for the ZBD-05, and the VN-16, the export designation for the ZTD-05, making Venezuela's Marine Corps the first Latin American force to operate Chinese amphibious assault platforms at scale. Thailand's Marine Corps followed, acquiring both types, placing Chinese amphibious technology directly into the militaries of countries with access to the same maritime approaches that Chinese naval strategy prizes. In March 2025, photographs from Chinese test facilities showed a new generation amphibious IFV prototype bearing hull numbers 003 and 005. The new vehicle carries an unmanned turret with no visible crew positions inside. Active protection hard-kill systems are mounted on the hull. The barrel geometry suggests a different main armament from the ZBD-05. The road wheel spacing has been modified. The Type 05's replacement is already running. And while Norinco was solving the amphibious problem, it was simultaneously building a completely different kind of vehicle, one that would eventually outnumber every tracked platform in the PLA's inventory by a significant margin. Chapter 6. The Snow Leopard, China's Wheeled Revolution, and the Export Weapon. There is a version of armored vehicle doctrine that prizes tracks above all else. Tracks grip mud, climb obstacles, distribute weight across soft ground. Tracks are what tanks use. Tracks, in this view, are simply better. And then there is the reality of the PLA in the early 2000s, trying to project mechanized forces across the vast distances of Chinese territory into rapid deployment scenarios. Along road networks that a 30-ton tracked vehicle destroys on contact, tracks are slow on roads, wheels are fast. Norinco began developing the ZBL 9 inches the 1990s. A 6x6 prototype was spotted in road tests in 2006. The formal 8x8 production vehicle made its public debut on the 1st of October 2009 in the Beijing Military Parade marking the 60th anniversary of the People's Republic, rolling past Tiananmen Square in front of the world's cameras. The Snow Leopard, as it came to be known, is built on the VN-18X8 chassis, combat weight between 15 and 20 tons depending on configuration. Powered by a Deutz BF6M1015C liquid-cooled diesel producing 440 horsepower, it reaches 100 km per hour on road. It is also fully amphibious, reaching 8 km per hour in water using twin propellers at the rear. The ZBL-08, the IFV variant, carries a two-man turret with a Ukrainian-derived 30mm automatic cannon and an HJ-73C anti-tank missile launcher on each side. 7 combat-ready passengers. Protection against 12.7mm rounds across the frontal arc. But the ZBL-09 family is not defined by any single variant. It is defined by what the same chassis can become. The ZSL-10 is a basic APC with a heavy machine gun. The ZSL-09 is a command vehicle. The PLL-09 mounts a 122mm howitzer, or in its larger version, a 155mm gun, making it a self-propelled artillery platform. The PTL-09 is an anti-tank gun carrier. The ZTL-09 is a tank destroyer. And the ZTL-11 also designated ZLT-11, fits a 105mm rifled gun into a fire support vehicle role, the Chinese equivalent of the American mobile gun system, built for rapid fire against light armor and fortifications in combined arms brigades. Total production of the entire Type 08 family exceeded 6,150 vehicles as of available data. That is a production number that exceeds the entire armored vehicle inventories of most European NATO member states taken individually. The export record confirms the Snow Leopard's appeal. Argentina purchased 110 VN1 vehicles, the largest single export order for a Chinese IFV at the time of the transaction. Venezuela's 2012 package included the VN1 alongside the amphibious platforms. Gabon, Nigeria, and Thailand have all fielded variants of the family. At the 2014 Zhuhai Air Show, Norinco presented the VN12, an export version of the ZBD-04A with bolt-on applique armor, certified to STANAG, 4,569 level 4/5 protection on the frontal arc. It was a direct pitch to buyers who wanted a tracked IFV competitive with the Russian BMP, 3M, and the German Marder. No confirmed export orders have been announced, but the vehicle's existence demonstrates how deliberately Norinco has positioned itself in the international market. The Snow Leopard's export customers are not buying a budget alternative to Western systems anymore. They are buying a platform that has been fielded in larger numbers than most of its competitors, maintained by an industrial base that does not run out of spare parts, and sold without the political conditions that Western arms exporters typically attach to major contracts. Chapter 7. What the numbers say: from 100 borrowed vehicles to the edge of the next generation. In 1950, the People's Liberation Army had no armored fighting vehicles it had designed itself, not one. By 2025, Norinco's production lines have delivered over 6,150 vehicles in the Type 08 family alone. The ZBD-04 family exceeded 3,075 tracked IFVs. The ZBD-05 amphibious family passed 1,000 vehicles. The ZBD-03 gave over 180 platforms to the airborne forces. The ZSD-89 reached approximately 1,000 APCs. The original Type 63 produced 8,000 vehicles across all variants. These are not small numbers. These are numbers that reflect an industrial machine operating at a scale that only a handful of countries in human history have matched. The story of how China arrived at those numbers runs through every method available. It starts with the Type 56 and Type 66, straightforward copies of Soviet designs in the mid-1950s. It moves through the genuine original engineering of the Type 63 inches 1964, the first vehicle China built without outside help. It takes a detour through the Type 85 and ZSD-89 tracked APC family, iterative improvements built for an army still searching for the doctrine that would define mechanized warfare for the next century. It reaches the ZBD-86, a copy of a BMP-1 accepted in 1986 but mass-produced from 1992, a vehicle that arrived in Chinese service so late that it was obsolete before the paint dried. Alongside it, the YW309 hybrid, the ZBD-86 turret on the Type 85 hull, a stopgap solution for a problem that should not have needed a stopgap. Then, the WZ-551 wheeled APC family in 1990, China's first wheeled armored design, which became the commercial platform, opened that export markets across 3 continents. Then, the ZBD-03 airborne IFV in 2002, giving paratroopers what they had never had before. Then, the ZBD 4 inches 2006, with Russian weapon system technology in a Chinese hull, finally giving the PLA a tracked IFV capable of matching what Western and Russian forces had operated for a decade. Then, the ZBD-05 and ZTD 5 inches 2005, the fastest amphibious fighting vehicles on Earth, built around a very specific operational scenario and achieving performance figures that no competitor had approached. And the Type 63A amphibious tank, itself a 1997 modernization of a chassis lineage stretching back to the early 1960s, finally retired by the ZTD-05, it had waited 40 years to be replaced by. Then the Snow Leopard family in 2008 and 2009, a modular wheeled platform produced at industrial scale, exported globally, and fielded in numbers that redefined what a medium-weight mechanized force looks like. Each transition in that sequence was forced by the one before it. The Type 63 was forced into existence by the inadequacy of the Type 56 and Type 66. The ZBD-86 was forced by the disaster of 1979. The ZBD-04 was forced by the inadequacy of the ZBD-86. The ZBD-05 was forced by the strategic requirements of an amphibious doctrine that had no room for slow vehicles crossing open water under fire. The principle that runs through the entire sequence is not ideology and it is not pride. It is necessity. Every gap in capability was eventually filled, using whatever method was available at the time, copying when that was all that was possible, buying technology when the money was there, and building from scratch when both options had run out or been cut off. The next amphibious IFV prototype, already running at Chinese test facilities in 2025, carries an unmanned turret and a hard-kill active protection system. It is being designed by engineers who have never had to ask a foreign country for a blueprint. The gap that existed in 1950 is not visible anywhere in that vehicle. The machine that could not move a single infantryman in an armored vehicle of its own design has become the only country outside the United States fielding two simultaneous fifth-generation fighter production lines and, on the ground, an armored vehicle industry that is building the next generation before the current generation has finished its service life. That is not a gradual evolution. It is a forced march that is not finished.